what is missing in current machine learning systems is reasoning, which is the ability to apply logic, context, and abstraction, which humans naturally just use them to learn from just a very few examples. In contrast, most modern machine learning systems, despite their sophistications, rely heavily on large amounts of data and statistical correlations rather than reasoning capabilities. So let me try to explain it by using some detailed examples. First, let's talk about feature learning, so humans can learn to identify a new concept with a very few examples. For instance, if you show a child just one or two images of a very specific bird species, they can often recognize that bird species in the new context or new settings, even if the background or angles of the image changes. This is possible because humans use reasoning to associate features like color, size, and even the big shape to a broader understanding of what is defines birdness, and then extrapolate these features to new species. However, in machine learning, we need hundreds of thousands of examples of that bird for a model to perform well in classification, even with advanced technologies like feature learning or transfer learning. Is still a struggle with this low data scenario, which is mainly because they lack of capability to reason beyond that raw patterns in the data. And the second is abstract reasoning in contextual learning. So humans are capable of reasoning abstractly and applying learned concepts in different contexts. For instance, if you know how to make a peanut butter sandwich, then you can easily infer how to make a sandwich with jam instead of peanut butter, despite you never having done so before. So this shows how humans can generalize and using common sense reasoning to adopt knowledge across different scenarios. But in contrast, machine learning models tend to struggle with applying learned concept to new or slightly altered environments. A common example is self-driving cars, though these systems are trained on massive amounts of data and perform very well in controlled environments, but unusual and some rare situation, for example, an animal are crossing the road in an unexpected way, then this system might fail because it lacks of reasoning ability to generalize from sparse data and reasons about the situation in a broader situation context. And the third is causal reasoning, which is beyond correlation. So humans can discern cause and effect relationships even from limited data. For example, if you see a ball rolling towards a glass and then you hear the glass shattered, you immediately reason that the ball caused the glass to break. Even if you haven't seen this exact event before, your reasoning ability lets you understand the causality from one or just two instances. But for machine learning models, particularly deep learning systems, they have struggled with this kind of reasoning. They can find correlations in data, but often fail to understand these causal relationships. For example, a model was trained on images of sunny weather and outdoor events might incorrectly associate with sunshine with outdoor events because it has seen them co-occurred frequently, but it won't reason that sunny weather causes people to go outside. This is because they are lack of the causal understanding, which is the major limitation in machine learning systems. And the fourth one is active learning and data efficiency, which is a struggle. So there has been significant error when we're developing a data efficiency approaches in machine learning, such as active learning, which is a model that selectively query the most informative examples to learn from few data points. However, these approaches are still heavily dependent on statistical patterns, and can't reason beyond the data that has been seen. For instance, in medical diagnostics, a human doctor can sometimes diagnose a rare condition after seeing only one or two cases due to reasoning and connecting the dots from prior medical knowledge. But as the machine learning model, however, maybe need to see thousands of such cases to perform similarly, unless explicitly programmed to handle such edge cases. So despite advantages like data-efficient methods like active learning are still far from the mimicking human-like reasoning. So why this happens? Let's try to focus on statistical learning. So current machine learning models are mostly based on statistical learning, where patterns and correlations in the large data set are used to make predictions. So this approach has led to impressive performance in tasks like image classification, like speech recognition, like natural language processing. And because these models rely on memorizing patterns from vast amounts of data, they lack of abstraction and reasoning ability like humans have. So humans combine both inductive reasoning, which making generalizations based on specific examples, and we also can do deductive reasoning to learn efficiently, which is like applying known principles to new situations, whereas the machines are still mostly limited to induction. What is the fundamental missing in machine learning is reasoning. It's not just more data-efficient methods. So humans can learn from few examples because they can reason and generalize in a way that machines cannot yet match. Although there are ongoing efforts to introduce reasoning into machine learning, such as symbolic AI and neuro-symbolic reasoning, but we're still far from replicating human-like cognitive flexibility in machine. So unlike machines can reasoning, they learn will remain constrained by the need for large data sets and statistical correlation, while humans continue to excel in data-sparse environments due to our reasoning abilities.